Friends, let us see the operation of counter type ADC. So here VA represents the analog input signal. So the 4 volt is the analog input signal. So practically speaking, if the boiler temperature is 40 degrees Celsius, then your RTD will generate 4 volt. That 4 volt is given to this comparator. Initially the counter will be in reset position. Reset means all the bits will be 0. The initial value of the counter is 0. So 0 0 0 0 B0 0 0 0 0. The bits are represented here. The weightage is 1 2 4 8. So if 0 0 0 0, if it goes to input to the DAC, the output of the DAC will be 0 volt. So the DAC, it converts 0 0 0 0 into equivalent analog value. That analog value will be 0 volt. That 0 volt is given to your comparator. Now your comparator compares plus terminal voltage and negative terminal voltage. So 4 volt is greater than 0 volt, so the comparator output will be 1. So at this condition you have to apply clock pulse. So here if there is no clock pulse, then it is considered as 0. So 1 and 0, according to AND gate truth table, the AND gate produces the output of the AND gate will be 0, so the counter will not be enabled. Now if I apply the pulse, if I apply a single pulse, so during this on period the clock will be 1. So 1 and 1, according to AND gate truth table, the output of the AND gate will be 1. So here I am applying only a single pulse, so the counter value will be changed from 0 0 0 0 1 to 1 0 0 0. So it means only one pulse is applied to the counter. So the last bit will be set 1. This value 0 0 0 0 1 is given to DAC. Your DAC, it converts this digital input and as an analog output. So this 0 0 0 1 is converted into analog equivalent analog value. That analog value is 1 volt. Again this 1 volt is given to inverting terminal of your comparator. Now your comparator compare 4 volt and 1 volt. 4 greater than 1. So now also the comparator output will be logic 1. If I apply second pulse, again the clock will be 1. Your AND gate will become 1. Again the counter starts counting the pulse. It will become 2. 0 0 1 0. Why it is 1? Because the number of pulses is equal to 2. So the second bit will become 1. This bit will be given as input to the DAC. This DAC converts this digital input into analog input, analog output. So the equivalent analog voltage will be 2 volt. This 2 volt is given as input to the comparator. 4 volt and 2 volts are compared by comparator. Again VA greater than 2 volt, 4 greater than 2. So the comparator output will become 1. Now if I apply third clock pulse, again the clock value will become 1. 1 and 1, the AND gate will produce 1. Again the counter will be incremented by 1. So totally 3 pulses. How will you represent 3 in digital form? 0 0 1 1. So 2 and 1s will be enabled. Again this value is given to DAC. So DAC will produce equivalent analog voltage 3 volt. So this 3 volt is given us here. 4 and 3 are compared. So logic 1 is produced. And again if I produce fourth clock pulse, again the AND gate will be 1. So the number of pulses are counted by the counter. So what is the equivalent value, digital value of 4? 0 1 0 0. It is given to DAC. DAC converts 0 1 0 0 into equivalent analog voltage. It will become 4 volt. For example, it is 4 volt. This 4 volt is again given to non-inverting terminal, inverting terminal of DAC comparator. 4 and 4 are compared. 4 greater than 4, no, the condition is false, so it will become 0. So if any one of the input is 0, the AND gate output will become 0. So the counter stops counting. So the digital output is 0 1 0 0. So there is the digital representation of 4 volt analog input. This is how the counter ADC work, counter type ADC works. Thank you.